today's my O2.
40, okay. We're working on our do now. No, you need to have your backpack in the zone. You need to get started on our class.
How was that for nurse?
Okay. Ashton, when Corey is seated and ready, will you explain to him why we're videoing? When Corey is seated and ready. Excuse me? Okay, well, that's okay for now. I need you in here. Will you please explain to him what we're doing, why we're videoing? Mark, you can open the homework and work on the homework. We have homework this week. Yeah, I'm in, sweetie. Thank you. Hey, Cam. Cam, will you come sit here today? Thank you. All right, for our do now question today, you were asked to look at this coral reef picture and predict how climate change could negatively affect it. Maybe you used prior knowledge, maybe you've heard of things like this before, maybe you just use what we've learned about climate change so far. Willow, what do you think?
Climate change could negatively affect the coral reefs because rising water temperature can kill the coral reefs. That affects other fish and organisms that live near or in the coral reef because their habitats would be uninhabitable.
So I heard you say rising water temperatures, okay? And I heard the word uninhabitable. What does that mean to you?
That means like the space is no longer able to be lived in, like how landfills used to be space that could have been used for animals or something. They're now uninhabitable and dangerous.
Good explanation. So that actually leads into the second question of how would that affect the fish and organisms that live in and on or near the reef. Would anyone else like to answer this? Layla? Any part you'd like. I love how I saw Peyton turn around to look at Lilo when she was speaking, and you brought in our other effect of climate change of melting glaciers, melting ice sheets. Very good. Who else would like to comment on our do now? Peyton.
For certain areas, they will, like, everything will die off because they will have no other perfect place to go. So, like, you know how we had the perfect level of greenhouse gases in our atmosphere?
Mm-hmm. Mm-hmm.
It's kind of like how they have the perfect water temperature.
Ah.
I think it was a video. We learned that like I think 90% of them or something, 80% of the energy that stays is in the ocean. So that's probably what's most effective.
Yeah, Peyton brought in evidence we've already gathered about climate change. She talked about a video we watched and it said that 90% of that extra energy is being absorbed by the oceans. Excellent memory. Yes, and it sounds like you've actually learned about coral reefs before because you said that they need to live in this like perfect temperature. Right, good. So we are going to discuss the oceans again today. Which sphere are the oceans a part of? Ashton? Hydrosphere, exactly. When we've talked about effects on the hydrosphere before, we'll review those. And we're going to look at how the ocean is affected by climate change. We're going to continue to talk about that. Can you please close your computers and put your eyes up here in 5. Close your computers. Eyes up here in 4. Looking for 100% computers closed. Eyes up here in 3. 100% computers closed. Eyes up here in 2. Almost there, 100% 1. And 0. Awesome. Can I have a volunteer for our first objective of the day? Roderick, go for it.
I can observe and explain the effects that the excess carbon dioxide has on Earth's oceans by following a procedure to conduct an experiment.
Good. Before we read the next one, let's break that one apart a little bit. So we are going to use this word a lot today, excess. What does that mean to you, excess? If I said, explain the effect of the excess carbon dioxide. Sophia?
The not needed carbon dioxide.
The not needed. Does anyone have another way to explain it? Jack?
It's like the more than needed or more than normal.
Exactly. More than normal, more than needed. The extra. Nora, that's what you're going to say? Yeah. Now let's talk about carbon dioxide. What do we already know about carbon dioxide? What is something we've learned about carbon dioxide? Staya. It is a greenhouse gas. What else? What else have we learned? Like, for example, how does it interact with the energy that comes from the sun? Remember our simulation? Roderick?
So it interacts with the energy that comes from the sun by reflecting it back down to Earth when it's trying to like go back up into space.
Exactly. So carbon dioxide molecules. So that's a greenhouse gas that traps more of sun's energy onto the surface of our Earth. What's another greenhouse gas we've learned about? What's another one? Cam. It's not up there, but I know you know it in your mind. What's another one? It's just on the tip of your tongue, the tip of that finger. Do you want to phone a friend? Anyone know? Cam will call on you. What? Methane, absolutely. Good. Okay, so next one. Who can read the next objective? Sophia, all the way in the back.
When there's a positive effect, describe how the human enhanced greenhouse effect and the extra carbon dioxide emitted by human activities affects that.
Excellent. Yes. I want you to talk to your table. I want you to come up with the difference between the human enhanced greenhouse effect and the natural greenhouse effect. Go.
The natural greenhouse effect was over here, but the human enhanced greenhouse effect is what we did, like burning fossil fuel is our automobiles causing the earth warming, basically.
Do you agree?
I agree.
I think that sounded like a really good explanation. So, which part?
The whole thing.
The whole thing? Okay, that's fair.
I know what she's saying.
Yeah.
But like, humans gotta help.
Oh, okay. I see. So the greenhouse effect. It's a name
For the layer of gases on in our atmosphere. Yeah, so this is what we call it, the greenhouse effect.
I know, but humans.
Yes.
So I have the house effect.
You are part of it, yes. Let's listen to our peers. Yes, let's bring back together in 5, 4, 3, 2, 1. Who can raise their hand and say what their table came up with? What is the difference between the human-enhanced greenhouse effect and the natural greenhouse effect? I heard a great conversation happening over here. Mark, what you got?
Well, what I said was that the human-enhanced greenhouse effect is the greenhouse effect, except enhanced by humans.
Ah, it's the greenhouse effect, but enhanced by humans. That's true. That's good. Fabian, was that a hand? Can you expand upon that for us?
The human greenhouse effect is caused by humans, and it harms the earth and all the spheres, while the natural greenhouse effect, it helps the earth.
Ah, our natural greenhouse effect helps our Earth, while the human-enhanced greenhouse effect harms parts of our Earth, including the spheres. What was that? It affects the Earth. Can someone expand on that? That's another great base. Anyone else have any more thoughts? Jack.
The human-enhanced greenhouse effect, there are more greenhouse gases in the atmosphere, so when the sun comes down and it bounces around a lot before it comes out. In the natural greenhouse effect, there are less greenhouse gases in the atmosphere, so the sun comes down and it bounces around a lot.
Yeah, in the natural greenhouse effect, we have just the right amount of greenhouse gases to live on Earth, grow our crops. And Jack was saying that human-enhanced has more greenhouse gases. Peyton?
So the human enhanced keeps the heat and energy like in our atmosphere more, and the natural greenhouse effect lets it kind of hang around like the rim of the atmosphere. So it keeps our Earth like warm, but it's not like too hot.
Gotcha. Why is it human-enhanced? I don't understand. What's the human part? What do humans have to do with it, Leila?
Because we're burning more fossil fuels, we're releasing and making more factories, we're releasing more carbon dioxide and methane into the atmosphere.
Right. It has to do with our human activities. Exactly. Fantastic. Okay. So we have talked about a lot of different effects of climate change and their effects on the different spheres. We have talked about wildfires. We have talked about, what else have we talked about? What are some other effects of climate change that we've already covered? Think maybe about your personal presentation. What was your personal presentation about? Cam? Hurricanes. So more frequent, more intense hurricanes. What else have we learned about other effects of climate change, consequences of climate change? Mark?
Wildfires.
Drought, absolutely. Roderick?
It causes more, the polar vortex is larger.
Polar vortex, totally. Jack? Sea level rising, flooding. Our people in Tuvalu are losing their home, their island. Yes. So we've talked about a lot of different things. Today, we are going to learn about a new effect called ocean acidification. Who thinks they can make a prediction either based on something they already know or on the words ocean and acidification? What could that be? Actually, you know what? Let's turn again, talk to someone at your table. What do you think ocean acidification is going to be? Go.
When the ocean has pH, the pH of the ocean is more acid and warming up.
This table's been so quiet so far. What do we think? What does it sound like?
The oceans have acid.
The oceans have acid. Okay, yeah, I see ocean and I see the word acid. Totally. Do you agree?
Yeah, I do agree.
Good. Okay. All right, let's bring it back together. 5, 4, 3, 2, 1. All right, raise your hand if you can tell us what your table came up with. What do we think ocean acidification is, either based on our prior knowledge or maybe the words? I'm seeing a trend. We've talked about trends. I'm seeing a trend of the same people raising their hands. I love hearing from those people, but take a risk if you haven't said anything yet. Taylor.
So I see acid, like if you break down acidification.
Right here. Yeah.
So Basically, more acid and gases in the ocean.
More acid and gases in the ocean. That sounds super plausible based on the words. Abril, is that what you were going to say? Yeah. Sophia?
I know it's bad because acid makes trip hard.
Okay, so it's a negative thing. All right. Roderick?
Okay, so I know a little bit about pH and so I don't remember the scale, but the pH of the ocean is more towards it's more acid-like, I guess.
Okay. Okay.
The pH.
Something to do with pH scale. Interesting. Well, we are going to watch a video about ocean acidification. We're going to watch it twice. The first time, we are going to listen and learn. The second time, we are going to seek out the answers to our 2 prompts, the causes of ocean acidification and the effects. Please write both of these prompts on a whiteboard. Go. I got a line. Nora is next, and then you may go.
Miss, can I get another marker, please?
Sure, the windowsill. Excellent. Maisie is already writing the first prompt. Focused. Going quickly. Not wasting any time. Oh, what are you doing? Sorry.
You can have that.
Thank you. Excellent. Ziana already has the first prompt down on her board. Not wasting any time.
What?
Is it also down here? Oh no. Try again. I can see from all the way over here that Corey is on task, writing down the prompt on his whiteboard. We're having a major marker problem.
Well, thank you.
Just do what you can with those. It might be light, but that's okay. So again, we are going to watch this video twice. The first time, you can just listen. There are some science terms that we haven't heard before, but they're not above you at all. And the second time, we're going to actually answer our prompts. Okay, on our boards. Nora, you're going to give me that marker. Yaman's having a marker catastrophe.
I don't know if it's right either. Okay, not bad.
Not bad. Here's a fourth one for you to try. All right. So expectations in the video. You were sitting up tall. You were listening at a voice level 0.
You should have given me that instead.
Here we go.
By now you've heard that the way we're living is filling up our atmosphere with carbon dioxide. As a result, the planet's warming. Heat waves and floods are more likely to be extreme, and people's lives will get tougher. And the more we learn about climate change, the more risks we uncover. Since we started burning fossil fuels, the ocean has absorbed about half of all the CO2 we humans have put out. That's why it's called the planet's biggest carbon sink. Now this is good because it's kept a lot of CO2 out of the atmosphere. But as the ocean warms, it takes up less and less CO2. And with all that CO2 in the sea, scientists are shedding light on, well, an ocean of problems. Ready for the first big problem? Some sea creatures like clams, oysters, and coral, their shells and skeletons are getting weaker. Okay, you've got bigger problems than easy to crack clams? Maybe not if you're among the 1 in 7 people who get most of their protein from seafood, or if you understand how unstable the world would be with 1 billion more hungry people. What's weakening the shells? Well, these little creatures are going about their lives scooping up molecules called carbonate ions to be the building blocks of their shells. But when CO2 reacts with seawater, it releases hydrogen ions, which compete with shells for carbonate. With more hydrogen ions floating around in the ocean, our little friends have to spend more energy building their shells and have less energy for finding food. That means it's harder to grow, and more will die off before they get big. So the fish that eat the clams or live among the coral will have a harder time surviving, meaning the fish that dine on them won't have enough to eat, and so we won't have enough to eat. Remember those pesky hydrogen ions generated by more CO2? They don't just take away the carbonate ions that these little clams need. They also make the ocean more acidic. It's already become 30% more acidic since we started spewing all this CO2, and it could get much worse. We could change the ocean's chemistry so much that shells actually start to dissolve. That means if we don't turn this problem around, your great-grandkids might think of reefs the way you think of a dodo bird. And with 1 in 4 ocean species living in coral reef ecosystems, weaker coral could threaten the foundation of the whole ocean food chain. But why panic, right? Life always seems to find a way to adapt, but it needs time. In a few decades, we might make the oceans more acidic than they've been in 20 million years. It's hard to imagine any ecosystem quickly adapting to that big of a change. But things don't have to get that bad. We've started this problem, and we're going to fix it, beginning at its source, carbon dioxide from burning fossil fuels.
Okay, so we got to listen to it. I'm going to play again. This time you are seeking out the answers to the causes of ocean acidification. So I believe it was Taylor who said it sounds like the ocean is going to become more acidic, and that was exactly right. So let's listen for how is that happening? And because it's happening, what are the effects? What is happening because the ocean's becoming more acidic? All right.
By now you've heard that the way we're living is filling up our atmosphere with carbon dioxide. As a result, the planet's warming. Heat waves and floods are more likely to be extreme, and people's lives will get tougher. And the more we learn about climate change, the more risks we uncover. Since we started burning fossil fuels, the ocean has absorbed about half of all the CO2 we humans have put out. That's why it's called the planet's biggest carbon sink. Now this is good because it's kept a lot of CO2 out of the atmosphere. But as the ocean warms, it takes up less and less CO2. And with all that CO2 in the sea, scientists are shedding light on, well, an ocean of problems. Ready for the first big problem? Some sea creatures like clams, oysters, and coral, their shells and skeletons are getting weaker. Okay, you've got bigger problems than easy-to-crack clams? Maybe not if you're among the 1 in 7 people who get most of their protein from seafood, or if you understand how unstable the world would be with 1 billion more hungry people. What's weakening the shells? Well, these little creatures are going about their lives scooping up molecules called carbonate ions to be the building blocks of their shells. But when CO2 reacts with seawater, it releases hydrogen ions, which compete with shells for carbonate. With more hydrogen ions floating around in the ocean, our little friends have to spend more energy building their shells and have less energy for finding food. That means it's harder to grow, and more will die off before they get big. So the fish that eat the clams or live among the coral will have a harder time surviving, meaning the fish that dine on them won't have enough to eat, and so we won't have enough to eat. Remember those pesky hydrogen ions generated by more CO2? They don't just take away the carbonate ions that these little clams need. They also make the ocean more acidic. It's already become 30% more acidic since we started spewing all this CO2, and it could get much worse. We could change the ocean's chemistry so much that shells actually start to dissolve. That means if we don't turn this problem around, your great-grandkids might think of reefs the way you think of a dodo bird. And with 1 in 4 ocean species living in coral reef ecosystems, weaker coral could threaten the foundation of the whole ocean food chain. But why panic, right? Life always seems to find a way to adapt, but it needs time. In a few decades, we might make the oceans more acidic than they've been in 20 million years. It's hard to imagine any ecosystem quickly adapting to that big of a change. But things don't have to get that bad. We've started this problem, and we're going to fix it, beginning at its source, carbon dioxide from burning fossil fuels.
Take 1 minute, voice level 0, look at your board. Make sure you have answered the 2 prompts on your board. Maybe you push yourself and add a little more if you've already written something down. I'm going to walk around. That was our second time. I'm going to walk around. I want to see that everyone's written something for each prompt.
I like that word, that choice of word. Oop, I didn't. Awesome. That's a good thing to think about. Yeah, good. What did you hear as a cause? What's causing this? your shells. Boom. You know it. Put it down here. You know it.
Take about 30 more seconds.
These are good. This looks like your effect, right? Yeah.
This is the H plus the U, the
Yeah,
bad thing.
exactly.
Yeah, and this is the good guys.
Yeah.
Yeah, but then they go over then. That's the fish. This, then.
Yeah, perfect.
All right, so we're gonna get a chance to share our thoughts with our peers. We've done this a ton of times. You know what we're about to do. You are going to cap those markers. Oh, it's your favorite thing. You're gonna stand up with your whiteboards, pushing your chairs. When the music is playing, you are walking around. When the music pauses, you are sharing with someone. Playing the music again, walking around, pausing, new person to share with. Everyone stand up, push their chair in. Is everyone standing? Oh, I need to see everyone standing. All right, start walking around. Good walking, good walking. Keep it up. Big circles around the room, big circles. Share question 1 with someone near you.
Cause of ocean acid. I said that CO2 goes to the ocean.
Cool. What'd you write?
More CO2 in the ocean, more, it also makes things very hot. Oh yeah, hydrogen ions, I think, causing the ocean to be more acidic.
Good. Excellent. And start walking. Start walking. Hello. And a new person. Find a new person. Tell me. Or Noah. Go tell Noah. Quick.
I'll tell you mine.
Alright, so the effects of acidification is that people that eat fish can't eat the fish because the oysters don't have enough protein in them for the other fish to eat them. They get protein in them.
When you are done sharing, go back to your seat. We're going to recap. 5, 4, 3, 2, 1. You have 5 more minutes. And, okay. So, let's recap. What causes ocean acidification? I heard a lot of great conversation. I know we know this. What causes ocean acidification? Yaman. What causes ocean acidification? Let's all show our respect and attention over this way. Yaman is speaking.
When I saw the video, I saw that these red things get in the ocean. They ruin our ocean, and then when fish cannot find any food, so, and then fish eats another fish and eats another fish, in the ocean will be no fishing.
So, Yaman is definitely touching on how important the ocean ecosystem is for the animals that live in there. He's talking about something about red circles. Can someone help expand on that idea? Stea?
The carbon dioxide that goes into the ocean causes hydrogen ions.
Uh-huh.
And then they eat and take away all of the carbon ions that we need in our ocean, help make like shells for clams and stuff.
Yes. So I'm going to go back to the video just to add a visual to this. So at the beginning, they talked about our ocean being the biggest carbon sink, meaning something that stores carbon dioxide. So it said half of all that extra CO2 that human activities, cars, factories, all those things we talked about, 50% of that extra CO2 is being absorbed into the oceans. And when that happens, Stea then told us that these little guys, these hydrogen ions, they are in the water. The extra carbon dioxide creates these hydrogen ions. These hydrogen ions are very pesky for the ocean and for the shelled creatures that live in the ocean. It takes, see, look at him taking that carbonate ion away from the shelled organism. So what are the consequences of that? What's happening to shelled organisms in the ocean? Ashton?
The shelled organisms are getting weaker, and it says that the shells are going to dissolve, just like my happiness.
Oh, yes. Yes, the shells are getting weaker, dissolving. How does that affect people? Oh, they talked about like the broader scope of things. Think outside of our community. What could happen for people? Giselle?
Yeah, it affects people by like the sea life and like the animals, like seafood, I feel like.
Yeah.
And that's how we get our protein most of the time, and it's gone.
Right.
Like, some of it's like disappearing because of this, so it's basically our fault.
Yeah, it's an important source of protein. Sienna, what do you want to add on?
Like also, it can like affect the people that live by the sea because like that's what they use to eating seafood. People just love shrimp, so shrimp is fun.
Yeah, it said 1 billion people could go hungry because they rely on seafood and these shelled organisms for their protein. I would love to continue to talk about this. You guys are amazing. I want us to have time to get to our experiment. So please wipe your boards, reorganize the table bins, make sure your desks are completely clear except for a pencil. Yes.
Is the experiment like partner, team, or like solo?
Team. Right here. Here's your team. Good question. Okay, let's have a completely clear desk.
Do we need to put our Chromebook on?
Yes, please. No Chromebooks either. 7. Completely clear. Only a pencil. Only a pencil in 6. Completely clear. Only a pencil in 5. 4. Oh, sorry, Yasha. Completely clear. Only a pencil in 3. 2.
This to
1. Let's see what tables have met that expectation. Ooh, I have team 2, completely clear desk. Team 5. Team 1. I even see some very clever people putting their name on their lab sheet that I passed out. Ooh. All right. Fantastic. So, I'll wait till I have 100%, voice level 0, attention back, ready to hear about our experiment. Thank you, Charlie, for turning towards me. Okay, so we're going to do an experiment today to see if excess carbon dioxide emitted through human activities has an effect on our oceans. Now, just like any lab we do, we need to make sure we have the appropriate leadership roles, one for every person, to help our lab go smoothly. We've done this before, but let me just really quick remind you what they are. We'll need a materials manager, someone to take care of the materials, make sure they're being used properly. We need a ruler of record, someone that is making sure that everyone gets accurate and complete data. A source supervisor who is mediating the interactions between people, making sure everyone is being kind and respectful. Keeper of procedures, making sure the procedure is being followed step by step in perfect order. You have a minute to decide, wait, If there are any arguments, rock, paper, scissors it out. Go. That's a good role for you. Absolutely. If that's the role you're actually doing. Is that the role you're doing? Fantastic. Great choice. 30 seconds to decide.
Number 3.
Mediate?
Store supervisor.
Period.
Oh.
Or period away.
What do you want?
15 seconds.
Make sure of it.
5. Voice level 04. 3. 2. 1. Okay. So, quietly, can I have every materials manager raise their hand? I should see one at every table. Great. Hands down. Can I see my rulers of record? I should see one at every table. Great. Hands down. Can I see my source supervisors?
Oh, me.
Thank you. Ooh, it seems like we're going to have to have a discussion, okay? With your team, because there seems to be some confusion. Let's come back to it. Last one, keeper of procedures. Great. Okay, so now let's go ahead and turn towards our procedure. I'm just going to do a short demo of it so we know what all the materials are, so we have a basic idea of what the procedures are, and then procedure keepers, you'll take over from there in making sure the procedure is followed perfectly. So can I have everyone turn towards me? I'm going to have volunteers reading the steps of the procedure. Who can read step 1? Mark, what's step 1? Everyone listening at a voice level 0, please.
Get supplies from supply table.
Perfect. So that's the supply table back there. What you'll have on your tray, so you can make sure, 2 plastic cups, a beaker, 2 Petri dishes, a cup, a paper cup that has baking soda in it, and a little tiny cup that has vinegar in it. Okay, step 2. Who can read step 2?
This is step 2?
Oh, make sure we're at 0. Sophie. Perfect. So we set the 2 cups side by side. Next step, Roderick.
Use the beaker to measure and pour 150 milliliters of the bromothamol blue mixture into each cup.
Good. So you have a beaker for a reason. You need to measure out 150 milliliters of bromothamol blue. Behind table 6 at the sink are 2 pitchers of bromothamol blue. Both of your cups. Oh, I've lost some people. Track back, please. Both of your cups need 150 milliliters of bromothamol blue. Okay? Yes?
So each 2 get a cup?
Sure, if that's the way you'd like to do it. You guys, I trust you. You can figure out who's going to do which part of the procedure.
Oh, there's 2 parts.
Yes.
Okay.
Yes, exactly.
White.
You'll see. All right. Let's see. Where are we? Are we on step 4? Thank you. Abril.
Place the paper cup inside one of the clear plastics containing the indicator solution so that the top of the paper cup is 1 centimeter below the top of the plastic cup. Make sure the bottom of the paper cup is not touching the surface of the liquid in the plastic cup. The paper cup should not cover.
Thank you. Okay, that's a lot. So let me go over that. This is really crucial. So I'll wait. So important right now. So this little cup goes taped in to this bigger cup, and just one of them. Now the idea is that you don't want the paper cup to touch the liquid. Now, 6th graders. If it touches the liquid a little bit, it's okay. I don't want it necessarily falling and spilling in the cup. That will alter our results. Are we ready to listen?
But I have a question.
But if it accidentally just dips in or falls in, no big deal. The tape that I have provided for you is not the stickiest, but I have a ton of extra pieces on the back table. If yours is not very sticky or you want to do 2 pieces, you decide that as a team. What I need is the little cup to look like this in the bigger cup. Does that make sense?
Yeah.
Fantastic. Ziana.
I'm confused though, because it's not gonna really be worth it because the tape's not gonna be strong enough. And once you put that liquid, it's gonna get heavy.
It should be strong enough. It should be strong enough. All my other classes have been able to do it. But if you need a second piece of tape, send someone to go get a second piece of tape. Leela. Oh, yes, 1 second. Mark, do you have a question?
Yes. Why does it say crumb on the little cup?
I don't know. Oh, that's because it's just the kind I bought. I don't know. Okay. Let's see. Number 5, Leela.
Before the reaction observation data report and back table below.
Okay, so after I've taped the cup, everyone turn to the back. Excellent job, Mark. Turn to the back. Turn to the back. See the data table? You write in the before section.
Miss, I think we know.
Good. Okay, Yama thinks we know how to do it. So turn back to the front. Turn back to the front. Fantastic. Let's do number 6. Who can read number 6? Ziena.
Carefully add 1 teaspoon of white vinegar to the paper cups containing the baking soda. Be careful to add 1 teaspoon of white vinegar to the paper cup containing the baking soda. Be very careful not to spill any vinegar into the integrated solution.
Okay, all eyes right here. I want 100% of eyes. I want to see all 28 pairs of eyes on me right now. Okay. This little cup is full of vinegar. You're going to pour it in the paper cup, not in the plastic cup. Okay? It needs to go in the paper cup. Mark.
But the paper cup, can you do that inside the plastic?
I know. It needs to go in the paper cup, not in the plastic cup. Okay. Capiche? Okay. Okay. Great. And, ooh, 7 super important. Who's going to read 7 for me? Ayat.
Immediately place the pastry dish over the top of each plastic.
So you better have people ready, hovering, so ready, because as soon as you pour that little bit of vinegar in the paper cup, you need to quickly put the Petri dish on top of the cup, okay? Immediately after, on both. I realize right now that I think I might have given you some Petri dishes that are too small. It's okay if they just kind of falls a little bit in. Maybe use the smaller one for the one without the paper cup. Yeah. Okay, we have to keep going because we don't want to run out of time. Number 8. Leela.
Wait 3 minutes before collecting after the reaction data.
Good, and then after 3 minutes, you'll see things happening. You'll go back to the data table. Any questions?
No.
Fantastic. So what's going to happen is we are going to spend, yes?
What if you put the cup in, what if you put the paper cup inside the fork and then put the blue stuff in?
You'd have to be really careful. Let's do the procedure keeper. Make sure you do it in the exact right order. Thank you for asking. Okay, you are going to take 2 minutes at voice level 0. I just want you thinking and writing a prediction. What do you think is going to happen to the cup with extra carbon dioxide? I have sentence stems here. After that 2 minutes is up, materials managers, you may then at that point look around your table, see that everyone has a 6th grade level prediction, a full sentence. If everyone does, you can get your materials and get started. So right now, you are thinking and writing a prediction. What's going to happen?
I'm done.
Okay, but add a sentence stem to it. Okay.
Hey, Ashton, what's going on today? Why are we so concerned right now about that raining? Do we need a break? You want a break? Can you go take a little break so you can come back and be ready? Go get a drink of water. Right.
Materials managers just wonder what the, sorry. Worry about the 3 right now, okay? It'll be okay. Okay, oh, I hear some noises. I should only see pencils writing. Got another 50 seconds. At the end of the timer, the materials managers may check. Okay, great. At this time, materials managers may check in with everyone else. As long as everyone has a 6th grade level prediction, you can get your materials and get started. Everyone ready? Cool. Lights are coming on.
When you were last year.
So we're gonna have supplies on the table, correct? Yep. Yep. All right. First, we place the 2 cups side by side. Use the beaker to measure and pour 150 milliliters of Brahmaful blue mixture into each cup.
Excellent keeping of the procedure. That's fine. I love how I see a check. Excellent. Yes.
Most of them are small.
That's okay. You know what? Grab the one from my demo. Grab one big one from the demo. Yeah, perfect. Ooh, that's smart. That's smart. Efficient.
It's not gonna. Your job. Your job.
Hey, sweetie, we wouldn't want any kind of chemicals to get on high horse, right? So let's keep it away. Sophie, get in there. Help out. Get in there. All right, yeah, so we're doing an experiment. Thank you for being a good friend. Be careful.
Why are we playing with this thing?
We're not playing with it. We're doing science with it. Good. We're doing an ocean acidification experiment. Would you like to watch?
Yes.
Yeah, absolutely. You can grab the back table if you want.
Okay.
Or even this team is open.
Then the other
What step are we on?
He got the Bengali on by 1 cup.
Cool.
It's a vinegar.
Okay, I know. You got it. Speed.
Will this kill you?
If you drank it, or what? Or if you just looked at it?
Will it poison you if you look at it?
That's a good question. Well, we never drink things, right? Because we're just never sure, especially because our bodies can react differently to different things. I don't know that it would kill you, but I wouldn't want to find out the hard way.
Could it poison you and like make you sick but not sick enough to die?
I bet it would make you feel really sick. Yeah. Ooh, are we ready? Good. Did you guys do the before data? Oh, we did. Do that really quick. You guys. You decide. That's okay. No worries. Do your before data. And no worries.
Cup A, this is cup A, this is cup B.
Fantastic.
I want to put this in.
Not yet. You got to do your before data.
We have to...
Yeah, okay. You can put that one in.
Right now?
It's okay if it's snow. It's okay if it's okay. But is there any way that I can help you right now? I see that you're distressed.
Which one is B?
Okay, talk to me if you need me, okay?
We're gonna die. Miss, I have
For the before reaction, what are we describing?
What you see in the cups. A little tricky, but what is it that you see in the cups right now? Roll with that. Yeah.
We have to put it on this.
Could you do me a favor? Understand that's pretty distressed right now.
Him?
You know what?
Yasha,
Okay.
ask him what's going on. He'd be shy to talk to me because I have the...
Hey guys, we should probably put it on.
I haven't had a piece today, but keep calling.
it was happening.
And what are we talking about? That's okay, right?
Okay.
That's okay. That's okay.
Should we not touch it?
Don't worry about it. Ooh. I appreciate that you wanted him to be with this team, but next time just say, Yaman, your team needs you. Do you mind joining your team?
Never mind, let me not.
That's okay. There's always a nicer way we can say it, though, right? Yeah. Excellent, excellent. You see something happen inside the little cup? Do we pour the vinegar in? Okay, good. Good. Bubbling.
Actually, Zion, she is actually. Because, like, she did basically half of the work and Blaine did some, and everybody did some. And I told them just leave the thing, the last thing for Yasha to pour that. And they said, well, Yasha's not here, too bad.
I appreciate you sticking up for your friend. Yasha's giving all help right now. Do me a favor. I don't want you to miss the experiment. Stick with your table. I got Yasha. Thank you, sweetie. Don't worry about it. No big deal. It's okay. It's okay. It's okay that it is. It's not that. That's fine.
Okay, it just goes like that.
Oh, we want to be able to totally seal it off. So can we actually lower the cup a bit? Thank you for asking.
That was unexpected.
No, that's fine. That won't change the... It actually didn't flip or anything, so it didn't pour anything out, so we're still good. We're still good.
Oh.
Our cup fell in the water. It's okay.
Can we pour everything back and do another?
No, it's fine. It's not a big deal. Not a big deal. I didn't... It would be worse if it had flipped in the water, right? No big deal.
Okay, ready?
Hey, Cam, sweetie, we don't need our computers right now. Oh, you were doing the time? Oh, that's a good idea.
But basically, do a little bit more time.
Whoa!
Oh yeah, 10 just ours.
Yeah, it takes a while.
Do you feel like that's sealed at the top?
Miss Wellington, it's not like close.
Keep your hand on it. Yeah, yeah. No, you're doing a great job.
What kind is it? Is that what's supposed to happen?
What?
Did you just put that on?
No, it just keeps falling off.
Oh, that's okay. Oh, it's okay.
Bacon chicken nugget.
I love Swivl. Uh-oh.
Miss Wellington, what happens if it gets on us?
If what gets on you, Sienna? If what gets on you? Oh, it'll just stain a little bit, but you'll be okay.
Oh, I'm sorry.
You're okay. I'm gonna help your reaction just a little bit. I think I might have given you a little too little vinegar. We'll just see. Will you open that for me?
Yeah.
Yes. But let's not.
I love
Will you hold this down to make sure that it's nice and sealed? Thank you. Can I have everyone's attention up here? Thank you. Let's have your attention up here in your seat. We're just going to take a really quick break from our observations. 5, 4, 3, 2, 1. And now I don't see everyone seated. So I would like to help add a little more evidence, add a little bit more to our experiment. So someone, I believe it was Roderick. Hi. You were the one that mentioned earlier the pH scale, correct? So we are looking at a pH scale up here. I'm going to wait. Thank you. So here is a pH scale based on what we can see, our observations. The color indicates the pH level of the solution. And in this case, we are using bromethylene blue mixed with water, which simulates our ocean because it has a pH of approximately 10. Would you agree with that? Based on the cup that we didn't do anything to?
Yes.
Do you agree it's about a 10?
Yes.
So this is the color, the pH level of our cup that we did not add excess CO2 to. For your after the reaction, I want you and your team to discuss what color, what pH level the cup with the excess CO2 has now become. So go ahead and discuss that with your table. Go.
It's like
Then keep observing.
No, but that's because they're like that was how it was.
Taylor, place a whiteboard behind both of them. See if it's easier. And Yaman, sometimes we don't see things in an experiment when we expect to, and that's okay too. You could look at other tables as well. But come on this side, Yaman. Maybe the white background will help you see it a little bit better.
And then there you go and do it.
So what color do you think yours is?
Here's 4 or 5. 4.
And hey, look. What does that say? Oh, good. Like that. Yeah, those are 6th grade level sentences. Yasha and Yaman, please focus in with your group, okay? Focus in with your group.
Can me and Yasha do the experiment together advisory? Because like he's gonna do nothing.
I love that idea. Let's do that. I'll set that up. I love that idea.
He will be able to do Spanish class.
Got it. Yasha, we will definitely do that this week, okay? Totally. 5, 4, 3, 2, 1. Thank you. So let's see. Team 5. That's Ashton, Leela, Steya. What color would you say your cup with excess CO2 has now become? Okay, a 4 or a 5. And if I'm looking at this correctly, Team 5, does that mean that your ocean water has become more acidic or more basic? More acidic. Team 2, what do you think right now? I know that you still wanted to have some more time to observe, but what color do you think your cup with excess CO2 has become?
It's about a 4.
About a 4, okay. Team 3, how about you guys? Did you see any change? No, not much change? Okay, that's okay. Sometimes our experiments don't go exactly the way we planned. That's all right. Luke?
Ours is like a 10, but it has like a 3 and 4 glare.
Oh, interesting. Parts of it are a 10. Parts are a 3 or 4 kind of glare to it. Very interesting. Team 4, what about you guys? Same? Maybe it hasn't fully done its chemical reaction yet. Maybe if we leave it for a little while. In fact, why don't we do that? Why don't we continue to let our cups do their thing while you take 5 minutes. Yeah, 5 minutes to fill out the reflection and analysis piece with your team. Go ahead and do that. Full 6th grade level sentences. Go ahead, go. Excellent job. Leela restated the question in her answer. My hypothesis was... Can't wait to see what she said. Yeah.
I accidentally did for the reaction first, then the stuff.
Oh, can you just relabel it for me? Yeah. Yeah. Just let me know what you're doing. That's okay. Oh, go for it. Oh, interesting. Yeah. Do what you need to do. Was your hypothesis based on temperature?
A little bit, yeah.
What did you say?
I said that the temperature might increase, but I don't think we have it in like sun or anything, so...
But maybe the reaction could have caused it to change temperature?
Bless you.
Thank you. Maybe. Go for it. See if you were right. Cam, how are those sentences coming?
It was the night. It was the night.
Oh.
It was the night.
Why?
Because I was assuming that it was going to look exactly the same the entire time.
Yes.
But it didn't. They changed color.
Good. Can we use the word rejected instead of not?
Or you know what? Yeah, let's do it. I see. You guys can see a difference?
Yes. There is a blue.
I see a greenish tint to it now. I see it's more like a 9. Yeah. I wonder what happened. It's okay.
We messed up.
I don't think you guys messed up.
Well, we like bopped a little.
No, well, it's not gonna do different.
Because this one was too big.
Yeah.
So it wasn't completely sealed.
Oh, okay.
And we switched.
I think it's changing more and more now that I look at more and more.
Yeah, we just gotta wait.
Yeah.
I use my phone to like shine the flashlight on this so we can see better.
For a second. for scientific purposes.
Why do you just don't put lotion down there?
I'm sorry. Let's go ahead and put that away for now since we have an experiment out, right? Thank you.
I'm trying to wipe it up.
Sure, go ahead. Well, that's pretty cool.
Compared to the other one. Oh, that's pretty.
That is pretty.
Okay.
2 more minutes to finish your reflection and analysis.
Orange just got up by himself and
There you go.
by himself. We didn't touch it. We didn't do anything.
There you go. See, we just need to be a little patient. That's cool. Now, so figure out what number it is. Whoa! Look at that change. What number is it now? Okay.
You guys want to know what my nickname was in first grade?
About a minute left. A minute left. Make sure your 2 reflection and analysis questions are done. Hi. So what do you think? How do our observations of this experiment translate to what's happening in our oceans?
That they're changing color.
Interesting. Interesting. Okay. The color. Well, the color just helps us know what the pH level is.
It's like turning hotter. Yeah. Because like that being outside in water, and like it's not really that's it's not really fast.
Oh, well, so, okay, I see where the confusion is. So, when we look at the color, as it gets into what color would you say this is? Which one? Okay, and do we see what that means? It's more what? So, the color is just a way for us to see if it's acidic or basic. So, what is happening when more carbon dioxide? It becomes more, which is worse for the environment. There you go. Yes.
More acidic.
Because you have carbon dioxide. Worth a try. I don't think so, but worth a try. Okay.
I'm not a
3, 2, 1, and 0. Eyes are up here. So I just had a really great conversation with Fabian and Sophia about this question, and I want to hear what you guys think as well. So how did what we observed in our experiment, how do we translate that to what's actually happening in our oceans? How does this demonstrate our real-world phenomenon of what's happening in our oceans? Jack?
Well, my observations connect to what's happening on Earth because it shows that increased carbon dioxide in the atmosphere causes more acid accumulation.
Right. So more carbon dioxide in the atmosphere causes more, or our oceans to be more acidic. Peyton?
I said my observations show how the human enhanced greenhouse effect is affecting the oceans and how the oceans are becoming more acidic.
Yes. Leela? Oh, excuse me. Let's put that back.
I'm gonna drink it.
Let's listen.
The marine life under there, they're dying out because they're not used to that, the amount of acid in the water in the ocean is inhabitable and unsafe to drink.
Good. So, Mark, last thought, and then we're going to wrap it up.
Okay, so for question 2, this is what I said. The ocean is turning green.
I'm really glad you brought that up. I'm glad you brought that up because that actually might be a little bit of a misconception we have in the class. So let me go back. So this color, guys, our oceans aren't necessarily changing colors, although maybe we could look into science about that. What is this color showing us? What does a change in color show us? Not that the oceans are changing color, but what is it showing us, Luke?
Well, the oceans should color
Interesting. Okay. So that again is about our ocean colors. What does this color represent, though? Right, the pH. So the color here, guys, was just a way for us to visualize. This was just a way for us to visualize the pH level. This wasn't to show us that our oceans are changing colors. What is it meant to show us? That our oceans are
Green.
not green. Yaman?
Are more active.
More acidic. Right. Yes, I know what you meant. More acidic. So this was showing us that when we added carbon dioxide to, what does this cup represent? The ocean, our world. Why did we put a lid on top? What is that showing? What? Roderick?
The greenhouse gases. The atmosphere. The atmosphere.
The atmosphere. This is the atmosphere with the greenhouse gases that are added to it, causing our oceans to become more
acidic.
There we go. There we go. Yaman.
What is that blue thing? What is it? Don't tell me it's ocean. I know it. Well,
Bromethmyl blue.
what?
Bromethmyl blue.
Oh, I thought it was water because I was gonna say, okay, so whether organic the water is gonna change.
Okay, so cleanup instructions. Can I have everyone's eyes back up here? You guys have been fantastic. You did a fantastic job with this experiment. Can I have everyone's eyes? Awesome. So this is what we need to do to clean up. Your tray needs to end up looking like this. So you have to put the paper cup and the little tiny cup back on the tray. You dump the water out, rinse out the cups. So the tray has 2 petri dishes, 2 cups, 2 big cups, a paper cup, a tiny little cup. Source supervisors, you are writing out of 3 points how many points your team deserves based on how they conducted themselves while conducting the experiment. Okay? Let's have 3 minutes to clean up. Go.
Wait, so do we keep the paper cup?
Yeah, you can just take it out and put it on the tray.
Okay. Ours just tip it over.
Yes, you may. Source supervisor.
May we throw this cup away?
That's okay too. Yeah.
Vinegar drink kill you if you drink by yourself?
No, I drink apple cider vinegar all the time.
Miss.
No.
Miss, like from what the highest number they can give? Because mine's kind of in the
Out
middle.
of 3.
Miss, make it this. Wait,
Out of 3.
it doesn't say to throw.
But it's okay. You can if you can because we're the last class for today. Cam, what's your role, sweetie? Okay, so you have a Post-it right here. You need to be writing out what you think what your group deserves out of 3. Say that again?
Don't we end at 118?
Yes. So we got to get going.
We scored 14.
Yeah, we got to get going.
Wait, should we bring them up there?
Yeah, that'd be great.
Okay, so wait, would I die if I